Okay. So good afternoon all. So first of all, let me know whether audio and video everything clear. Yes. Akshay Arun, good afternoon. Okay. So if audio and video is not clear, please let me know here. So please let me know if audio and video is not clear. Right. Okay. So I hope everything is clear, right? Okay. So we are dealing with the subject electromagnetics. Okay. So we are dealing with the subject electromagnetics, and we are dealing with the topic magnetostatics. We are dealing with the topic magnetostatics. Okay. So in magnetostatics we have studied about Lorentz force equation and its applications. So then we have studied Biot and Savart's law. Then we have seen Biot and Savart's law. Okay. So what is Biot and Savart's law here? So we have already studied here. So dB bar, so that means the small differential B field due to a small differential current element is given by Biot and Savart's law. So that is mu by 4 pi into what? I dl bar cross AR cap divided by what? Divided by R square. So here R is the distance from the current element. R is the distance from the current element to the point where we are trying to determine the B field, right? And AR cap is the unit vector along RR. AR cap is the unit vector along R. So always we consider AR cap as what? It is going to point away from what? Away from the current carrying wire, yes or no? Okay. So if you consider a small differential current element, so let us say this is I dl bar. So if you want to determine the B field at this location, then always we will consider this as what here? This as R bar. So that is the distance from the current element to the point where we are trying to determine the B field. So AR cap here, AR cap is the unit vector along R, okay. So AR cap is equal to R bar divided by what? Magnitude of R bar. So AR cap must always point from what? From the current element to the point where you are trying to determine the B field, right? Okay. So if we know how to determine the B field due to a small differential current element, then we can determine the B field. Due to a current element of finite length, and also we have determined the B field due to a current carrying wire of infinite length, and also we have determined the B field if you are having a square loop, yes or no? Okay. And if you are having a hexagon, so then how we have determined the B field at the center of the hexagon. So and also if you consider an equilateral triangle, we have determined the B field at the centroid, right? And if you are having hexagon, okay, so we have determined the B field at the center of the hexagon, right? And if you are having the circular loop, if the current is flowing around the circular loop, then we have determined the B field at the center of what? At the center of circular loop, yes or no? So all these things we have seen here, right? Okay. Okay. So okay. So for circular loop here, what is the expression we got here? So if we consider a circular loop, and if the current is flowing in anti-clockwise direction like this, right? So if the current is flowing in anti-clockwise direction like this, let us say the radius of this circular loop is rho. Let us say the radius is rho. Okay. So we have applied what here? Biot and Savart's law in order to determine what? In order to determine the B field at the center of what? At the center of this circular loop. Yes or no? So what is the expression for B field we got here? B bar is equal to what? Is equal to mu I by what? Mu I by, how much we got here? Mu I by 2 rho. Okay, so if I consider this circular loop in xy plane, let us consider this circular loop in xy plane, then what is the direction of B field here? The direction of B field will point in which direction? Out of the board. Yes or no? Why here? Here the current is flowing in anti-clockwise direction. So from right hand rule, so enclose your 4 fingers around the current, then you are going to get what? The direction of B field. So the B field is pointing in which direction? The B field is pointing out of the board. That means it is going to point in AZ cap direction. Understood? Okay. So it is going to point in AZ cap direction. So this is what we have seen here. This is what we have seen. Right. Okay. Okay. Here. So next what we have done here? Next what we have done? So if we consider semicircular loop, here. So if we consider semicircular loop, right, if we consider semicircular loop, right, okay, so let us say this is semicircular loop. So the radius of this semicircular loop is, let us say, r or rho. Okay, you can consider rho. So this is the radius of this semicircular loop. So now what is the B field at the center of this semicircular loop here? So let us say the current is flowing like this. Let us say the current is flowing in anti-clockwise direction like this. Okay. So for if you consider the total circular loop, what is the expression we got? B is equal to what? Mu I by 2 rho. So for semicircular loop, what you are going to get? You are going to get the B field half of this one. Yes or no? So for this one. So yesterday in the previous session I have explained here all these things. Why we are going to get half of this, all these things I have explained. Yes or no? So in this case, while deriving this expression, we have taken the phi. We have taken the phi from 0 to 2 pi. Understood? So under that condition, we got this expression. Now here you are going to take the phi from 0 to what? From 0 to pi. Yes or no? So and hence here you are going to get what? The B field half of this one you are going to get. So that is mu I by what? Mu I by 4 rho. Mu I by 4 rho. Since here the current is flowing in anti-clockwise direction, the B field is going to point in which direction? Out of the board. Now here, according to this axis, according to this coordinate axis, the z axis will come what? Will come out of the board. So that means here the B field is going to come out of the board. So I am considering here AZ cap. Okay. Now if suppose in the same problem, if I consider the current in clockwise direction here, if I consider the current in clockwise direction, then the B field must point in which direction? It is going to point into the board. Okay. So under that case, you are going to get the direction of B field into the board, that is in negative z direction. Understood? Okay. Okay. So next, similarly, if I consider quarter part of the circle here, if I consider only quarter part of the circle. Okay. So let us say this is x-axis and let us say this is y-axis. Okay. Now I am considering only quarter part of the circle. Okay. So that means phi is going to vary from where to where here? Phi is going to vary from 0 to pi by 2. Understood? Okay. So here let us consider the current is flowing in anti-clockwise direction. So here what is the B field here? At the center let us say the radius of this one is rho. Okay. Now what is the B field at the center? Tell me what we got. So this must be half of this one. Yes or no? Okay. So here phi is varying from 0 to pi and here phi is varying from 0 to what? 0 to pi by 2. So it is going to be half of this one, right? Okay. Okay. So here we got the expression B bar is equal to what? Mu I by what? Mu I by 8 rho AZ cap. So all these things we have seen in the previous session itself, right? Okay. Okay. Right. Okay. Okay. So next okay. So is there anyone online here? Regular students? Paras Moon, Alok Kumar, Rahul Thakur. Is there anyone? Right? Okay, yeah. So next, yesterday I have asked one question here. Yesterday I have asked one question. Okay. So anybody done that one here? Anybody done that one? Yesterday I have asked one question here. So if you consider a current carrying wire, right? Okay. So let us say a current carrying wire of finite length. Let us say if I consider a current carrying wire of finite length like this. So I have asked, so this is current carrying wire of finite length. Okay. So I have asked that if I consider the point, if I consider some point P1, okay, so that is along what? That is along the current carrying wire. So that is along the current carrying wire. Okay. So the current is flowing in this direction. Let us say it is placed, on along Z axis. It is placed along Z axis. Okay. Now if I consider the point P1, along the direction of current here, that means along the wire, if I consider some point P1. So I have asked what is B field at this location, or if you consider some point, P2, okay, somewhere here below this current carrying wire. Okay. So at this point, what is the B field? Okay. So this is what I have asked in the previous session here. So that means nothing here. What I am asking here is, if you consider the point along the current carrying wire, okay, so it is a current carrying wire is pointing in which direction? It is pointing in Z direction. So along Z here, if I consider some point here, and along Z if I consider some point here, then what is the B field at this location and what is the B field at this location? So this is what I have asked. Okay. Rahul Thakur, yes sir. Okay, very good. Okay. So what is the B field here? Tell me. At point P1 and at point P2, what is the B field you are going to get? Tell me here. What is the B field we got? See, I have told already, we have already derived the B field at some point P, at this point. Okay. So let us say we have considered this as what? This as Y axis and this as Z axis, and X axis is coming out of the board. Okay. So at some point here, at some point P, we have determined the B field already. Yes or no? Okay. We have done all these derivations here, right? So the normal distance from here to that point is rho. We have considered the normal distance from this point, from the line to that point is rho. Okay. So whenever we try to determine the B field at a normal distance rho from the current carrying wire, so what we got here? So we have considered the angle made by this end. The angle made by this end is alpha 1, and the angle made by other end we have considered as alpha 2. So for this one we got B field here. We got B field is equal to what? Mu I by 4 pi rho into what? Into cos alpha 2 minus cos alpha 1 into what? Into A phi cap. So this is the expression we got. To determine the B field what? To determine the B field at this point P. Yes or no? Due to a current carrying wire of finite length. Okay. Now I am not considering the point anywhere in this region or in this region here. Okay. I am considering the point along the current carrying wire. Right. Okay. Rahul Thakur. Okay. No problem here. Take care here. Oh, sorry to hear that, Rahul Thakur. Okay, but some things will be is not in our control, right? Okay, okay, yaar. Sorry dear, sorry for that. I am also feeling sorry for whatever that is happened, right? Okay. See, whatever may happen in life here, so that is not the good decision, right? Okay, we have to fight here, we have to fight. Whatever may happen, we have to fight, right? Okay, yaar. Okay. Okay, yaar. So what I am saying here, so this is the expression for B field we got for a current carrying wire of finite length, right? Okay, now see here, if you blindly apply this formula to determine the B field at point P1 and at point P2, so what you are going to get, tell me? If you blindly apply the formula, you are just applying the formula to determine the B field at this point and at this point. So what you are going to get? See here, you may get that alpha 2. What is alpha 2 here? What is alpha 2? See here, alpha 2 is the angle made by this end. Let us say this end I am naming it as B and this end I am naming it as A, right? Okay, so now see here. So now what is the angle made by this end with P1 here? So if you consider the angle between this end and this point P1, what you are going to get? So this alpha 2 will become what? This alpha 2 will become how much here? So you have to consider alpha 2 will become this one, yes or no? Okay, so alpha 2 will become what? Alpha 2 will become 180 degrees. Alpha 2 will become 180 degrees. Yes or no? Okay, so the angle made by this end here, the angle made by this end, if you consider the point P1 here, okay, so then the angle made by this end will become what? Will become alpha 2 will become what? Alpha 2 will become 180 degrees, right? Okay, now what happens to alpha 1 here? What happens to alpha 1? So you have to consider the angle made by this end here, the angle made by this end with respect to P1 is how much here? It is also nothing but what? It is also nothing but you are going to get like this, yes or no? So here also alpha 1 will also become what? Alpha 1 will also become 180 degrees. Yes or no? Both alpha 2 and alpha 1 will become what? 180 degrees. So the angle made by this end, with this point P1, is how much here? Is nothing but 180 degrees. Alpha 2 will also become what? Alpha 2 will also become 180 degrees. So that means alpha 2 is 180 degrees and alpha 1 is also 180 degrees. Right? Okay. Now if you consider the point P2 here, below this line, somewhere here. Okay, now what happens here? Now alpha 2 will become what? What is the angle made by this end with respect to this point P2 here? So then alpha 2 will become what? Alpha 2 will become 0. Yes or no? Next, alpha 1 will become what here? So what is the angle made by this end with this point P1 here? So now here alpha 1 will also become what? Alpha 1 will also become 0 degrees. Yes or no? So if you consider for point P here, for point P2, alpha 2 will become what? Alpha 2 will become 0 degrees and alpha 1 will also become what? 0 degrees. Alpha 1 will also become 0 degrees and alpha 2 will also become 0 degrees for point P2. Understood? Okay, so in this case you may say that sir, since alpha 2 and alpha 1 for point P1, if you consider point P1, okay, so we are getting alpha 2 and alpha 1 as what? 180 degrees. So you are going to get 0 here. Okay, fine. Now if you consider point P2, so then we are getting alpha 2 as 0 degrees and alpha 1 is also 0 degrees. So cos 0 minus cos 0 will become 0 and hence B field at this point P2 and B field at this point P1 will become equal to what? Will become equal to 0. Will become equal to 0. So that may be your answer. Okay. But here, what about this row here? What about this row? If you are blindly applying this formula, okay, so here alpha 2 and alpha 1 will become same. Okay, if you consider the point here, then alpha 2 and alpha 1 will become same, that is 180 degrees. And if you consider the point P2, then alpha 2 and alpha 1 will become same, that is 0 degrees. So in both cases, the numerator is becoming 0. The numerator is becoming 0. Now what about this normal distance? What about this normal distance? See, normal distance will become what here? Normal distance will become what? If you consider the point along the line itself, then the normal distance will be what? Normal distance will become 0. Rho will be 0. So if it becomes 0, so in the numerator you are having 0, and in the denominator also you are getting 0. So 0 by 0 is what? Is indeterminate form. Is indeterminate form. Yes or no? Okay. So indeterminate form. So you are going to get indeterminate form, right? Okay. Okay. So sir, then how we have to determine the B field at point P1 and at point P2? So just see, whatever the formulas we have derived here, from where we have derived, what is the base? Base is nothing but what? Bayet and Savart's law. So from Bayet and Savart's law we have derived all these things, right? Okay, so you should not forget that base here. You should not forget that base. So base for all these formulas is nothing but what? Bayet and Savart's law. So go with the basic here. Go with the basic. You are going to get the correct result, right? Okay. So blindly I am using the formula, right? Okay. If you are not worried about rho, if you are not looking at rho, simply if you put 180, you are getting 0, fine. Next again for point P2 you are putting 0, 0, again you are getting 0, so you are putting answer as 0. But if you observe rho here, rho is also becoming 0, then you are getting 0 by 0, indeterminate form. Understood? Okay, so that means here by applying this formula we are not getting the exact result. So in that case, what we will do here, we'll stick to the basic. That is what? That is what here? That is Bayet and Savart's law. Right? Okay. So now what I will do here is see here. Now I will consider a small differential current element here. I am considering a small differential current element. Just apply Bayet and Savart's law here. That's it. Okay. So this is the small differential current element IDL bar. Right. So what Bayet and Savart's law says here? So the small differential B field, due to a small differential current element is what here? Is equal to mu I dl bar cross what? Cross AR cap divided by what? Divided by 4 pi r square. Okay. Now here dl bar is nothing but what here? This differential length is along z. So I can represent this I dl bar as what? I dz az cap. Now if you observe, what is r here? What is r? Tell me, what is r? So r is the distance from the current element to the point where you are trying to determine what? To the point where you are trying to determine the B field. So here at this point I am determining the B field. Yes or no? So that means the distance from the current element here, to this point P1 is how much here? Is nothing but what? Is nothing but r. Okay, so the distance from the current element to the point where you are trying to determine the B field. So that is nothing but what? That is nothing but r. Okay, and what I have told here, r bar will always point from where to where? From the current element to the point where you are trying to determine the B field. So that means here r bar is pointing in which direction? Z direction. Yes or no? Okay, so that means here r bar is equal to what? R bar is equal to So r bar is pointing in which direction? Pointing in Z direction. Understood? So what is AR cap here? What is AR cap? AR cap is nothing but what? Unit vector along r bar. So that means AR cap will become what? AR cap is nothing but what? Is nothing but AZ cap or not? Yes or no here? What is the unit vector along r bar? Here r bar is pointing along Z direction. That means you have to consider the unit vector along Z direction. What is the unit vector along Z direction? Is nothing but AZ cap. Yes or no? Okay. So here r bar is equal to r into AZ cap. It is pointing in Z direction. Understood? Now if you want unit vector AR cap, that is equal to what? R bar divided by what? R bar divided by magnitude of R bar. So that is equal to R AZ cap divided by R. So that means you are getting what? You are getting AZ cap direction. Okay. So I think this much detail is not necessary here. You can easily understand from here itself, right? Okay. Just in order to show you each and everything, I have written all these things, right? Okay. Okay. So R bar is pointing in Z direction. That means AR cap is pointing in which direction? AR cap will be along AZ cap direction. Okay. Now if you consider here you are having I in place of IDL. What you got here? I DZ AZ cap cross what? AR cap is also pointing in which direction? AZ cap direction. Understood? Okay. So divided by what? Divided by 4 pi R square. 4 pi R square. Here you are having mu. So this is nothing but dB bar. Understood? Now here AZ cap cross AZ cap, what you are going to get? AZ cap cross AZ cap is equal to what? Is equal to 0. Yes or no here? So if you do AZ cap cross AZ cap, what you are going to get? You are going to get 0. Here this is small r is not equal to 0. Yes or no? So this r is the distance from the current element to the point where you are trying to determine the B field. So this r is not equal to 0 here. R is not equal to 0 here. Okay. So r remains same. Understood? So r is some finite value. So that means denominator is going to be some finite value. And in the numerator, if you observe AZ cap cross what? AZ cap. So AZ cap cross AZ cap will become what? Will become 0. Will become 0. Yes or no? Okay. So that means what is the differential B field we are getting here? What is the differential B field we are getting at this point P1 is nothing but 0. So if the differential B field is equal to 0, then you can consider this current element or 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 this current element. Whatever the current element you can consider here along this wire. Okay. So for all those current elements, the total B field you are going to get what? You are going to get 0 only. Okay. So in this manner, I can say at point P1, what you are going to get here? What you are going to get? B field will be equal to what? B field will be equal to 0. Okay. Okay. Here. Now similarly, the same analysis we can do if I consider the point P2. Point P2. Now if you consider point P2, then what is the distance from the current element to the point P2 here? Let us consider the distance from the current element to this point P2 is R. Okay. The distance from the current element, okay, the distance from the current element to the point P2 is, let us say, now you have to consider it as R. Okay. Always R bar must point in which direction? From the current element to the point where you are trying to determine the B field. So this is R bar. Okay. So now in this case, R bar is equal to what? R into what? R into minus AZ cap. That means in this case, AR cap is equal to what? AR cap is equal to minus AZ cap. So in place of AR cap, you are going to get minus AZ cap. So that means AZ cap cross minus AZ cap will also become what? Will also become equal to 0. Okay. So that means along the line here, along this line, wherever you can consider the point, whether above this line you can consider or below this line you can consider, at any point the B field will become equal to what? The B field will become equal to 0. Okay. But if you follow this formula, if we follow this formula, then you are going to get what? 0 by 0, which is indeterminate form. Okay. So what generally students will do here is they will forget about this row. They will simply substitute here the values of alpha 2 and alpha 1, and they will simply say B is equal to 0. Anyway, finally here also we are getting the result same. That means B field is equal to what? Finally we are getting B field is equal to 0. Okay. Since we are getting the same result, they will think that whatever the analysis they have done, that is correct. Okay. So whatever the analysis they have done, that is correct, they will think. Okay. Because here they have simply put 0 here, and actual result is also 0. So that's why they will think this analysis is correct, which is wrong. Right. Okay. So here this row, normal distance row will become what? Will become 0. So you are getting 0 by 0, which is indeterminate form. Okay. So with this formula, you cannot determine what? You cannot determine the B field along what? Along the wire. So in this case, we will follow what? We will follow the basic. So that is nothing but what? Bayet and Savart's law. So from Bayet and Savart's law only we got all these results. Right. Okay. So I hope this is crystal clear here. Right. Okay. So if you are having any doubts, you can ask me here. Right. Parasmoon using limit. What limit here? What you are asking? Be specific here. I am not able to understand what you are saying. Using limit. Okay. See, what I am saying here is, if you are getting any results in this manner, just go through basic. Understood? That's what I am saying. Rahul Thakur, again sir, Bayat Savat law. Have you attended Bayat and Savat's law here, Rahul Thakur? Have you attended? Tell me, have you attended Bayat and Savat's law? Have you attended while deriving this formula? Tell me here, Rahul Thakur. No. Okay. It is nothing here, simple. I have revised now, so the same thing here. I will simply briefly explain. You can go through the previous lectures here. If you want in detailed manner, you can go through the previous lectures. So, but here, since you are asking, I will explain in a very brief manner. Okay. So, what is this Bayat and Savart's law here? So, if you are having a current carrying wire here, if you are having a current carrying wire, carrying the current. If you are having a current carrying wire, carrying the current. Okay. Now, if you consider a small differential current element, I am considering a small differential current element, so that is IDL bar. Now, if you want to determine the small differential B field produced by a small differential current element, that is given by what? That is given by Bayat and Savart's law. Okay, so what Bayat and Savart's law says here? Bayat and Savart's law is going to give you how to determine the B field due to a small differential current element. Okay, so if you are having a small differential current element here, and if you want to determine the B field at this location here, so since this is the B field due to a small differential current element, I am considering this as what? A small differential B field, So that is a dB bar. So here I want to determine this small differential B field due to a small differential current element. Understood? Okay. Now here the distance from the current element to the point where you are trying to determine the B field, we are considering it as what? We are considering it as R. So where R is the distance from the small differential current element to the point where you are trying to determine the B field. Understood? Okay. So this R here, must always point from where to where here? From the current element to the point where you are trying to determine the B field. So that means R bar must be always what? Must be always along this line. That means always it must point from the current element to the point where you are trying to determine the B field. Understood? Okay. So these things you have to remember. Next, what Bayat and Savart's law says here is the small differential B field due to a small differential current element is proportional to current element and is inversely proportional to square of the distance between them. The current element and the point where you are trying to determine the B field. Understood? Now, if you put equality here, then you have to introduce what? You have to introduce a proportionality constant. So that is nothing but mu by 4 pi into I dl by R square. So mu by 4 pi is nothing but a proportionality constant. Okay, now if you want the direction, of the B field, then you have to do the cross product. Here you have to do the cross product with what here? With AR cap, where AR cap is the unit vector, along what? Is the unit vector along what? Along R bar. Okay, so AR cap is the unit vector along R bar. Right. Okay, so this is what Bayet and Sever's law. This is nothing but Bayet and Sever's law. Okay, so here I have told that if you observe here, we are doing ideal bar cross what? Cross AR cap. So here you are doing the cross product between these two vectors. So that means the resultant vector must be perpendicular to what? Must be perpendicular to this current element as well as what? As well as AR cap. So what is the resultant vector here? Is nothing but this small differential B field. So this small differential B field must be what? Must be perpendicular to both this current element as well as what? As well as AR cap. So that's what I have told here. DB must be perpendicular to what? Perpendicular to ideal bar, and also a DB must be perpendicular to what? Must be perpendicular to AR cap. Right. Okay. So this is what I have told. Right. Now in this problem we try to determine the B field at this point P1. If I consider some point P1 at this location. Okay. So now what will happen? So this R bar will move like this. Yes or no? This R bar will move like this, and it is going to lie what? It is going to lie along this line itself. Understood? So that means here this R bar is going to point along which direction? Let us consider this axis. As Z axis here. Okay, so now the point is lying here. So this R bar now is going to move like this, and it is going to point in this direction, because at this point you want to determine the B field. Understood? Okay, now R bar is pointing in which direction? It is pointing in Z direction, and ideal bar is also pointing in which direction? That is, current element is also pointing in which direction? Z direction. So the current element is pointing in Z direction, and R bar is also pointing in Z direction. So AR cap is nothing but what? Unit vector along R bar. So that means what is the unit vector along Z direction? Is nothing but AZ cap. So AR cap will also become what? AZ cap. Now AZ cap cross AZ cap will become what? Will become 0. So that's what I have told here. Okay, so if you consider any point along the line here, then you are going to get what? You are going to get B field as 0. So whether you consider here or you consider here in this region. Okay, along the line, if you consider any point along the line, then B field is going to be what? B field is going to be 0. Understood? So that's what I have told. Right? Okay. So is this clear here, Rahul Thakur? Okay. Okay, yaar. And all these derivations, if you want to know all these derivations, then go through the previous lectures here, because they will take more time. Okay, so I can't explain them again, so we can go through the previous lectures, right? Okay, so how we have derived these expressions and all these things, right? Okay, okay. Fine. Right. And okay, so what are the conclusions here? So along the line here, along the line or along the wire, at any point B field is equal to what? B field is equal to 0. Next, if you consider a circular loop of radius rho, the B field at the center is equal to mu I by what? Mu I by 2 rho. Next, if you consider a semicircle of radius rho, so then B field at the center is equal to mu I by 4 rho. Next, if you consider only a quarter part of the circle, okay, if you consider only a quarter part of the circle, due to this one, the B field at the center, let us say this radius is rho. Okay, what you are going to get? B is equal to what? Mu I by what? Mu I by half of this one. So that is 8 rho. Okay, so these are the things we have studied here. Okay, so this is the summary of all our lectures. Okay, all our previous lectures, right? Okay. Okay, so now I will give you some different problems here. I will give you some different problems. Okay, so you have to tell me the answer here. You have to tell me the answer. Okay, see, always try to tell the direction of B field by using what? By using right hand rule. It is going to be very simple here. Okay, now here, if the current is flowing in anti-clockwise direction, then the B field must point in out of the board. If the current is flowing in clockwise direction, then the B field has to point into the board. Understood? Okay, so in this manner you can easily tell the direction of B field, right? Okay, yeah. Okay. Parasmoon. Okay. So I will give you problems here. You have to tell me the answer for these problems, right? Okay. Okay. Okay, so tell me the B field at point P here. Tell me the B field at point P. So here consider this axis as x axis and this axis as y axis here. Consider this axis as x axis and this direction as y axis. Upward direction consider as y axis and this direction from left to right consider it as x direction, right? Okay. So tell me the B field at point P here. What is the B field at point P? At point P, what is the B field? What is the B field? Tell me. Parasmoon, what you are asking here? Yesterday's question of straight line. That's what I have explained here. I think you came late, right? I think you came late. Okay. I have explained all those things, right? See here, that's what I have explained here, right? So straight line wire, what is the B field at this point and what is the B field at this point? So all those things I have explained, right? And that question only I have given as a homework now for you, right? Now tell me here, what is the B field at point P? What is the B field at point P? Tell me. So here you are having a current carrying wire okay, of finite length, and here you are having another current carrying wire of finite length, and here you are having a quarter part of the circle. Here you are having a quarter part of the circle. Understood? Okay. So now they are asking the B field. They are asking the B field at this point P. At this point P. Tell me here. Tell me. So you just divide this into sections here. You consider this as first section, and this part as second section, and this part as third section. So consider this as what? Consider this as first section, and consider this part as second section, and consider this part as third section, right? Okay. Okay, mu I by 8 R. Okay, very good, Rahul Thakur, right? Okay. Now see here. Now if you consider, forget about 2 and 3 here, consider only 1. Okay. If you consider this point here, this point is along this line. So just now we have seen that if the point is lying along the line, then B field is equal to what? Due to this one, the B field will be 0. Okay. So due to the first section here, B field at point P will be equal to what? Will be equal to 0, right? Okay. Next, similarly, due to the third section here, if you consider third section, so this point is also lying along this line, Okay. If the point is lying along this line, then the B field due to this current carrying wire will be equal to what? Will be equal to 0. So that means due to third section also, B field is equal to what? B field is equal to 0. Next, what is left out here? Only this quarter part of the circle. So what is the expression for B field at the center due to a quarter part of the circle here? So just now we have seen, yes or no? So for quarter part of the circle, if you consider, the B field is nothing but what? Mu I by 8 rho, where rho is the radius of this curvature. Understood? Okay. Now here the radius is nothing but what? Radius is nothing but R. Right. Okay. So due to second section, B field is equal to what? B field is equal to mu I by what? Mu I by 8 R. Right. Mu I by 8 R. And what must be the direction of B field here? What must be the direction of B field? Tell me. What must be the direction of B field? What is the direction of B field? Just if you analyze all these things here, see how simple it is. See, if without analysis of all these things, if I directly give this problem, the student will feel very tough, right? Okay. So they will feel like this problem is very tough, but it is very simple. Yes or no? Okay. Okay. So what is the direction of B field? Tell me. What is the direction of B field? See here, the current is flowing. In which direction? Clockwise direction. So if the current is flowing in clockwise direction, the B field must point in which direction? Into the board. Yes or no? Okay. So here, due to this one, the B field must point into the board, and here we have considered this as x-axis, this is y-axis. So z-axis must come out of the board. Into the board means it is in negative z direction. So that is negative z direction, right? Yes, very good. Okay, so what is the total B field here? So total B field is equal to what? Is equal to B1 plus B2 plus what? B3. B1 plus B2 plus B3. So due to B1 it is 0, B2 it is mu I by 8R. So only for the first problem I am writing all these things here. Okay, so from next problem onwards you have to tell me the answer directly. Okay, so therefore the total B field is equal to what? Is equal to mu I by 8R, minus AZ cap, right? Okay, so this is very simple problem, right? Okay, next problem here, okay. So I hope this is clear here. I hope this is crystal clear, right? Okay. So next problem here. See, if you are having any doubts, please ask me here. So here, right? Okay. Okay, so let us consider the current here is flowing like this, here it is flowing like this, here it is flowing like this, and here it is flowing, and this is how the current is flowing around this loop here, around this loop, right? Okay, now now let us say the radius, this is the center here, this is the center, so the radius of this loop, let us say the radius of this loop is a. Okay, the radius of this semicircle here, the radius of this semicircle is a, and the radius of this semicircle, bigger semicircle, is what? Is b, right? Okay, now determine the b field here, determine the b field at the center. Tell me here, you have to tell me the answer. Tell me the answer here. Just divide this into sections here, semicircular section, and if you are having a straight line path, consider it as a current carrying wire of finite length. Okay, so we know the expressions for B field due to a current carrying wire of finite length, and if it is a semicircular shape, how to determine the B field, right? Okay, so all these things we know. So just tell me the answer here. Tell me the answer. So the current is flowing like this, it is flowing like this, and here it is flowing like this, and it is flowing like this. So it is flowing around this closed loop like this. Understood? Then what is the B field at this center? At this center. Very simple question here. Tell me the answer. So consider this one here, consider this one as first section, okay, and from here to here, consider it as second section, right? And this line, consider it as third section, and this semicircular ring, so consider this as what? Consider this as fourth section. That's it. Okay, so the problem will be completed. So tell me here, tell me. I am expecting some answers from you here. Rahul Thakur, Parasmoon, right? Mu I by 8, A minus B by AB. Okay, okay, fine. Mu I by 8 or 4 here? Mu I by 8 or 4? It is semicircles, right? Okay, now see here. So I have divided this into 4 sections. This is first section, and this semicircular loop of radius B is second section, and this straight line is third section, and again this semicircle of radius A is fourth section. Okay, so the total B field here, the total B field is equal to what? The total B field. So let us say this point, is P. Okay, so at point P, so the total B field, is equal to what? So due to how many sections I have divided? 1, 2, 3, 4. So B1 bar plus what? Plus B2 bar plus what? Plus B3 bar plus what? B4 bar, right? Okay, so due to the first section here, so if we consider only this section, okay, so the point is lying along the line, and hence B1 will be what? B1 will be equal to 0. Yes, okay. Next, B2 here, so that is due to this semicircular loop, second one, Okay, due to this second section, what is the B field at the center here? What is the B field at the center? Tell me, what is the B field at the center? So the B field at the center due to a semicircular wire of radius B. So what is the magnetic field? So just now we have seen here, that is nothing but what? Mu I by what? Mu I by 4 into radius of this semicircle. What is the radius of this semicircle? Is nothing but B. Okay, now you have to write the direction of B field here. Now consider, forget about all the other sections here, consider only this second section. Okay, so if you consider only this second section, the current is flowing in which direction? The current is flowing in anti-clockwise direction. So if the current is flowing in anti-clockwise direction, the B field is going to point out of the board. The B field is going to point out of the board. So out of the board means in which direction? This is x-axis and this is y-axis. Out of the board means it is positive z direction. So that means B2 bar will be in which direction? Positive z direction. Positive z direction. Right. Okay. Next, if you consider third section here, so this is also a straight line, right? Okay. Now this point P is along the line. So if the point P is along the line, then the B field at that point will be what? Due to section 3, the B field at point P will become what? Will become 0. Right. Okay. So due to B3 also, due to third section also, the B field, that is B3 is equal to what? Is equal to 0. Next, B4 here, B4. So B4 is due to what? Is due to this semicircular loop. Yes or no? So this is semicircle, it's of radius what here? Its radius is A. Its radius is A. So what is the B field due to a semicircle of radius A here? So is nothing but what? Mu I by what? Mu I by 4A. Mu I by 4A. Now if you observe here, the current is flowing. Consider only fourth section here. Now here the current is flowing in which direction? In clockwise direction. So if the current is flowing in clockwise direction, the B field at this point is going to point in which direction? It is going to point into the board. Into the board means negative z direction. Right. Okay. So mu I by 4A, it is going to point in negative z direction. Right. Okay. Now therefore the total B field here, therefore total B field is equal to what? Is equal to what you are going to get here? So mu I by 4 you can take common. So into 1 by B right, 1 by B minus 1 by A into AZ cap. 1 by B minus 1 by A into AZ cap. Yes or no? So mu I by 4 I have taken common. So 1 by B AZ cap. Here minus 1 by A AZ cap, minus 1 by A AZ cap, right? Okay, so I have taken AZ cap outside, then I can write it as 1 by B minus 1 by A. So or I can write the same thing as, see here. Now here which is greater and which is smaller here? So here in this problem we got here B is greater than what? B is greater than A. Yes or no? B is greater than A. Understood? So I am going to write this one. Here B is greater than A here, B is greater than A, that means here 1 by B is less than what? 1 by B will be less than A, 1 by A. So 1 by B is less than 1 by A means here you are going to get what? You are going to get some negative value. So if you are getting some negative value here, then what is the resultant direction of B field you are going to get? You are going to get some negative value. Yes or no? So that minus multiplied by AZ cap is going to point in which direction? Negative Z direction. So that means the resultant B field will point in which direction? Negative Z direction. Okay, or if you want you can write in this manner here, the same expression you can write in this manner, that is mu I by 4 into what? Into 1 by A minus 1 by B into what? Into minus AZ cap. So in this manner also you can write. Understood? Okay. Now here 1 by B is lesser than what? 1 by A. So this value will be what? This value will be positive. Understood? Okay. So what is the resultant B field direction here? So the resultant B field direction will be in which direction? Will be in negative Z direction. Understood? Okay. Okay. So is this problem clear here? Tell me. See, you can write in this manner or in this manner, it doesn't matter, both are same only, right? Okay. So here I have taken minus common and I have written in this manner, that's it. Okay. Okay. Is this clear here? Tell me. Is this problem clear? Yes, Rahul Thakur, Paras Moon. Yes, yes. Tell me here, is this problem clear? Yes? Okay. So next problem here, next problem. So next problem, write down next problem. A wire is bent, write down here, write down along with me, bent into the shape, bent into the shape, bent into the shape shown in figure. A wire is bent into the shape as shown in figure. Okay, so here they have given figure here, they have given figure. So here they have given figure. Okay. Okay, so this is the figure here, this is the figure. As shown in figure. As shown in figure, and the B field is measured at point P1, is measured at point P1 So that is B1, that is B1. Okay, so that is B1. So here they have given that the same segment, the same segment of wire, the same segment of wire, the same segment of wire is then bent into a, is then bent into a, is then bent into a semicircular shape, is then bent into a semicircular shape. See, I have seen this problem just before the session here. So I thought it is this problem is somewhat interesting, so that's why I am writing this problem. Okay. So if I would have seen this earlier, I would have already written this in on board. Okay, but just before the session I have seen this problem. Okay, and I thought it is better to explain in the class itself, right? Okay, so the same segment of wire is then bent into a semi-circular shape as shown in the figure, as shown in the figure. Okay, so here they have given the figure here. Here they have given the figure. Shown in the figure. So this is the figure here. This is the figure they have given, right? Okay, so what they are asking here is, and B field measured, and B field measured at point P2, at point P2 is B2, at point P2 is B2. Okay, is B2. B2 when the current is again, when the current is again I, when the current is again I. So if the total length of the wire, if the total length of the wire is the same in each case, if the total length of the wire is the same in each case, is the same in each case, is the same in each case, then what is the ratio, what is the ratio of B1 by B2, what is the ratio of B1 by B2? Okay, so that is what they are asking here, that is what they are asking. Okay, so this is the question they have given here. So what is the question here, what is the question they are asking? See here So they have given that a wire is bent into the shape as shown in figure. So this is the figure they have given here. This is the figure they have given, right? Okay, so this is the figure they have given, and the B field is measured at point P1. At point P1 is B1. So at point P1 is B1. So you can write easier. Okay, at point P1 is B1. The same segment here, the same segment of wire is then bent into what? Bent into a semicircular shape as shown in the figure. The same segment of wire is bent into a semicircular shape. As shown in this figure, right? And B field measured at point P2 is B2. B field measured at point P2 is what? Is B2. Okay. When the current is again I. So that means whatever the current that is flowing, okay, here the same current is flowing here also. Understood? Okay. Next, what they have given here, if the total length of the wire is the same in each case. So that means whatever the length of the wire here we are considering, here also the same length you have to consider. Okay, here also you are going to have the same length. Understood? Then in that case, what is the ratio of what? What is the ratio of B1 by B2? So that means here you have to determine the B field at point P1, and here you have to determine the B field at point P2. Then you have to take the ratio of B1 to what? B1 to B2. Right? Okay. So that's what they are asking here. So let us say this radius here, this radius of the semicircular loop is capital R. Okay. So do this one here. Do this one here. They are asking to determine the ratio here. They are asking to determine the ratio of B1 by B2. Okay. Do it here. I will give 2 minutes time. Do it and tell me the answer. Let us say this is figure 1 and let us say this is figure 2. Okay. So this length is L, and from here to here the length is 2L, and from here to here also it must be what? It must be same L, and from here to here it is L, right? Okay. And from here to here it is L, from here to here it is L, and this is semicircular loop. So they are asking the ratio of what? B1 to B2. Tell me here. If you want, you can consider x-axis in this direction and y-axis in this direction. So z-axis will come out of the board, right? Okay. Here just they are asking the ratio here, ratio of B1 to B2. That means they are asking the ratio of these magnitudes. That's it. Okay. So tell me the answer here. So 2 minutes time I am giving here. 2 minutes. What is there here in this case? This is length L and this is length L, and this point P1 is along this line, and this point P1 is also along this line. Understood? Okay. So that means at this point P1, due to this section and due to this section, it will be 0. Understood? Next, here the current is flowing in upward direction. So if the current is flowing in upward direction, okay, so the B field at this point is going to point into the board, right? Okay. So here the current is flowing like this. Okay, so due to this section, what must be the B field here? What is the B field? So we know the formula, that is mu I by what? Mu I by 4 pi rho into what? Into cos alpha 2 minus cos alpha 1. So you have to determine alpha 2 and alpha 1 values. That's it. Okay, so always you have to consider alpha 2 and alpha 1 in which direction? In anti-clockwise direction. So Parasmoon, do it here. So 1 minute completed here, 1 minute completed, 1 more minute. One more minute here, 1 more minute. We know here, we know already how to determine the B field due to a current carrying wire of finite length, right? Okay, how to determine the B field due to a semicircular loop. So all these things we know already, right? So just apply those here. You have to know how to apply all those results. So I think today Alok Kumar is absent, right? So Alok Kumar is absent. Okay. Okay, yeah. So that 1 minute is also completed. So total 2 minutes completed, right? Okay. So I know that I have to solve this problem anyway. Okay, you are not going to give the answer. I know that. Okay. Okay, yeah. See here. So here they have given, or I will copy that figure here. Okay. Okay, so just what you have to do here, so just that's what I have told here, just divide this into different sections. So let us consider from here to here first section, and here to here second section, and from here to here third section, from here to here fourth section, from here to here fifth section. That's it. Okay, now due to this first section and fifth section here, we know we can directly write due to this first section and due to this fifth section, the B field at point P1 will be equal to what? Will be equal to 0, because the point P1 is lying along the line, Okay, so I can write directly, B1 equal to what? B1 is equal to 0, and B5 is also equal to what? Is also equal to 0. Now next consider second wire, second section, this section. Okay, so how it is looking like? So it is, so this is the second section, right? Okay, so you have to determine the B field at this point P1, right? Okay, next at this point P1, and this length here, this length is L, so this is what they have given. Now so this is the end of the second section, and this is the another end of the second section, right? So this is second section here, so you have to determine the B field at point P1, understood? Okay, now we know that due to a current carrying wire of finite length, which is at some normal distance, let us say the normal distance from the wire to this point P1 is how much here? What is the normal distance from the wire to this point P1 is how much? Tell me. See, this total length is 2L. So what is the distance from here to here? The distance from here to here is nothing but what? Half of this 2L. Yes or no? So that means the distance from here to here must be what? Must be L. So that means the normal distance from here to here must be what? Is nothing but L. Is nothing but L. Okay. Now, so we have determined normal distance. Next, what you have to determine? You have to determine alpha 1 and alpha 2. So alpha 2 is the angle subtended by the alpha 2. What we call here? Alpha 2 is nothing but decreasing angle, and alpha 1 is nothing but what? Increasing angle. Understood? So why we are calling it as decreasing angle and why we are calling it as increasing angle? So all those conventions I have explained in the previous session itself, right? Okay. Now see here. Now this end here, this end is going to, this end is making an angle. This end is going to making an angle. So this angle here. So this angle we call it as what? We call it as alpha 2 or alpha 1. Tell me. So see how you have to determine that here. If you extend this wire here, if you extend this wire up to infinity, if you extend this wire up to infinity, what happens to this angle? This angle is going to decrease. So this angle we named it as what? Decreasing angle, and decreasing angle we'll consider it as what? We will consider it as alpha 2. Right. Next, if you extend this wire here, if you extend this end, if you extend this end here, if you extend this end, okay. So if you extend this end, then the angle is going to what? Angle always you have to measure in which direction? In anti-clockwise direction. So if you go on increase this angle here, sorry, if you go on increase this end here, end up to infinity in this direction, then what happens to the angle? It is going to subtend. Is nothing but what? It is going to increase. It is going to increase. Right. Okay. So here always you have to consider the angle here. Always you have to consider the angle in which direction? In anti-clockwise direction. In anti-clockwise direction. So this angle is nothing but what? Is nothing but alpha 1. So as you extend this end here, as you extend this end, this alpha 1 is going to increase. Is going to increase. So that's why we have named it as increasing angle. Okay. Now here alpha 1 is how much here? If you observe, what is alpha 1? What is the angle alpha 1? Tell me. What is alpha 1? What is alpha 1 here? Tell me. Tell me here. Rahul Thakur, Parasmoon, tell me. Tell me what is alpha 1? What is this angle alpha 1? Tell me. Okay. Always you have to consider the angle in anti-clockwise direction. So this angle, okay. So this angle here, this angle is nothing but what? Is nothing but alpha 1. So what is alpha 1? What is the angle alpha 1? Tell me. Is 90 degrees. Very good here. So alpha 1 is 90 degrees, right? Okay. Okay. And what is alpha 2? What is alpha 2? Tell me. What is alpha 2? So alpha 1 is equal to 90 degrees. Alpha 2 is equal to how much? Tell me here. Alpha 2 is equal to how much? See, this will form what? This is forming a right angle triangle or not? Yes or no? So this side length is L, this length from here to here the length is L. So what is alpha 2? Huh? I am saying each and everything, just give me the answer here. So here this is L, right? So what is angle alpha 2? Alpha 2 will be what? 45 degrees, right? Okay, very good Parasmoon and Thakur, very good here. Okay, so alpha 2 is equal to what? Is equal to 45 degrees. Okay, so alpha 1 is pi by 2 and alpha 2 is pi by 4. Okay, right? Okay, so now just apply the formula here, just to apply the formula. So what is the B field at point P1? At point P1. So due to this section 2, so that means I am representing B2 is equal to what? Is equal to mu I by what? Mu I by 4 pi rho, where rho is the normal distance from the line to this point P1. So the normal distance here is nothing but L. So mu I by 4 pi L into what? Into cos alpha 2. Alpha 2 value is pi by 4. So that is cos alpha 2 minus cos alpha 1. Alpha 1 is pi by 2. Okay, now what is the direction of B field here? What is the direction of B field? Tell me. So here the current is flowing in which direction? The current is flowing in upward direction. Consider only this section here. The current is flowing in upward direction. So if the current is flowing in upward direction, here the current is flowing in upward direction. So if the current is flowing in upward direction, then the B field at this point P is going to point in which direction? It is going to point into the board. It is going to point into the board. Yes or no? Okay. So into the board means which direction here? Negative Z direction. So B2 bar is going to point in negative Z direction. In negative Z direction. So this is B2 bar. Now here what is cos pi by 4? What is cos pi by 4? So cos 45 degrees is 1 by root 2. Cos 90 degrees is 0. Okay. So what you are going to get? You are going to get mu I by 4 pi L, mu I by 4 pi L into what? Into 1 by root 2, 1 by root 2 into minus AZ cap. So this is B2 bar, this is B2 bar, right? Okay, okay, yeah. So next, okay. Next, consider this line here, consider this segment. Okay, so now due to this segment, what is the B field at this location here? What is the B field at this location? So consider only this section here, consider only this section. Here you can tell directly here, here you can tell directly what is alpha 1 and what is alpha 2. Okay, so here you have to consider the angle subtended by this end, the angle subtended by this end. So the angle subtended by this end at this point, and the angle subtended by this end, right? Okay, so always you have to measure the angle in which direction? In anti-clockwise direction, in anti-clockwise direction. Okay, okay, so that means here you have to measure the angle, you have to measure the angle anti-clockwise direction here. Now here you have to measure the angle in which direction? Always you have to measure in anti-clockwise direction, right? Anti-clockwise. Okay, okay, wait here. So you have to measure the angle in anti-clockwise direction, right? Okay. So here you are having, I am drawing the section here, third section separately here. Okay. Okay. So third section here, third section. Let us consider third section. So third section is present like this, right? So its length is 2L, and at this point P1 you have to determine the B field, you have to determine the B field. Okay, so the normal distance from here to here, the normal distance from here to here is L, right? Now you have to determine the angles here, you have to determine the angles. So this end, so this is one end and this is another end, right? So what is the angle at this point? What is the angle made by this end of the wire here, by this end of the wire? You have to consider always the angle in anti-clockwise direction. You have to consider the angle always in anti-clockwise direction. So that means you have to consider like this. Okay, next for this end, okay. Okay, so this angle here, this angle, oh, okay, so this angle is nothing but what? This you have to measure in anti-clockwise direction here. So I am confusing between clockwise and anti-clockwise. Okay, fine. Okay, so this is nothing but what? This is You have to measure the angle in anti-clockwise direction like this. Okay, now if you extend this wire here, if you extend this wire up to infinity, so what happens to this angle here? What happens to this angle? This angle is going to decrease. Yes or no? So that means you have to consider this angle as what? Decreasing angle, that is alpha 2, and this angle is going to increase. As you go on extend this wire, this angle is going to increase. This angle is going to increase. So you have to consider this angle as what? This angle as alpha 1. Right? Okay. Now just apply the formula here. What you are going to get? So this section we have considered as what? Third section. Right? Okay. So B3 here, B3 bar is equal to what? Is equal to mu I by what? Mu I by 4 pi into normal distance. What is the normal distance from the wire? Is nothing but L. Okay, mu I by 4 pi L into what? Into cos alpha 2. What is alpha 2 here? What is alpha 2? What is this angle? So from here to here, the length is what? The length is L. Okay, and what is the length from here to here? From this point to here, from here to here, the length is what? L. Understood? So this is L and this is L. So this forms what? This is forming a right angle triangle. So alpha 2 will become what? Alpha 2 is nothing but 45 degrees. Alpha 2 is nothing but 45 degrees. Okay. So cos 45 degrees. So this is alpha 2. Right. Next, minus cos alpha 1, minus cos alpha 1. So what is this alpha 1 here? So this angle here, this angle is 45 degrees, right? So alpha 1 will become what? 180 minus what? 180 minus 45. So this angle here, this angle is 45 degrees. So this alpha 1 will become what? 180 minus 45, that is 135 degrees, 135 degrees. So here you are going to get cos 135 degrees, cos 135 degrees. Okay. Okay, so okay here. So now what is the direction here? What is the direction? So here the current is flowing in this direction from left to right. So that means it is flowing in this direction. So if the point is lying above the wire, it will point out of the board, and here the point is lying below the wire. So if the point is lying below the wire, then the field is going to point into the board. Yes or no? So if the current is flowing like this, the field is going to circulate like this. So above the wire it will come out of the board, below the wire it will go into the board. So this point P1 is present below the wire, so the B field is going to point into the board. So into the board means what here? Into the board means minus AZ cap. Into the board means minus AZ cap. Right? Okay. Okay, yeah. So here cos 45 is 1 by root 2 minus what? Minus cos 135 is minus 1 by root 2. Okay, so therefore B3 bar here, B3 bar is equal to what? Mu I by 4 pi L into 1 by root 2 plus 1 by root 2. So that is 2 by root 2. So that is you are going to get root 2 into what? Into minus AZ cap. Okay, so this one I can write it as here, if I write 4 as 2 into 2 here, if I write 4 as 2 into 2, so then you are going to get mu I by what? Mu I by 2 root 2 pi L, okay, minus AZ cap. So if there are any calculation mistakes, please let me know here. Please let me know if I do any calculation mistake, right? Okay. Okay. So I hope this is also correct. So that is for third section. Next what you are having here? Fourth section. Okay. Okay, so due to this fourth section, so this length here, this length is L. So from here to here, this length is L, right? Okay. Now this is one end. This is one end of the wire, and this is another end of the wire, right? Okay. So due to that section, fourth section, you have to determine the B field at point P1. So due to fourth section, what is the B field you are going to get? Tell me, what is the B field you are going to get? So it is just like practice here. It is just like practice, right? Okay. So here you are having a current carrying wire, right? So here the current is flowing in downward direction, right? Okay. Now we are trying to determine the B field at this point, P1. So this is one end and this is the other end. Okay. So the length of this wire is nothing but L. Okay. Okay. So so what is the angle subtended by this end here? So what is the angle subtended by this end? always you have to consider the angle in anti-clockwise direction, anti-clockwise direction. Okay. Okay. So always you have to consider the angle in anti-clockwise direction, right? So anti-clockwise direction means like this, yes or no? So this is anti-clockwise direction. So that means this you have to consider as what? This is anti-clockwise direction, right? Okay. Next, this end here, this end also is going to subtend some angle at this point P. So always you have to consider the angle in anti-clockwise direction, right? Okay. So anti-clockwise direction means you have to consider like this. Yes or no? Okay. Now if you extend this end here, if you extend this end up to infinity, if you extend this wire up to infinity, then this angle is going to increase. So increasing angle, we named it as what? Alpha 1. And if you extend this wire, up to infinity, so this angle here, this angle is going to decrease, so this decreasing angle, we have named it as what? We have named it as alpha 2. Okay. So just you have to understand how to apply this formula here, Okay. So if you know the normal distance, and if you find out what is alpha 1 and what is alpha 2, then the problem will be completed, right? Okay. So what is the normal distance from here to here? The normal distance from here to here is nothing but what? Is nothing but L. Okay. And this distance is also L, so that means alpha 2, what you are going to get? Alpha 2 you are going to get 45 degrees, and here alpha 1 what you are going to get? Alpha 1 you are going to get 135 degrees. Yes or no? So since here this is 45 degrees, so this angle alpha 1 is nothing but what? 180 minus 45, that is 135. Okay. So now this is fourth section here, right? This is fourth section. So B4 here, B4 is equal to what? Is equal to mu I by 4 pi into normal distance from here to here is nothing but what? Is nothing but L into what? Cos alpha 2. What is alpha 2 here? Alpha 2 is 45 degrees minus what? Cos 135. Okay. Now here the B field is going to point in which direction here? See here, current is flowing in downward direction. On this side the B field is pointing out of the board, and on this side the B field is going to point in which direction? Into the board, Okay. So that means B4 is pointing in which direction? Negative Z direction, Now here cos 45 is 1 by root 2, cos 135 is minus 1 by root 2. Okay. So you are going to get mu I by 4 pi L. So here the same result here also we are going to get here. Right? Okay. Okay. So what you are going to get? B4 bar is equal to what? Is equal to mu I by what? Mu I by 2 root 2 pi L minus AZ cap. Right? So this is the expression you are going to get. So if I have done any mathematical calculation mistakes, please let me know here. Please let me know if I have done any in B4 alpha. Oh yes. Very good Parasmon. Very good. Sorry here. So here alpha 2 is what here? Very good Parasmon. Sorry. Alpha 2, I have done a very silly mistake here. See here, alpha 2 is what? Alpha 2 is 90 degrees, right? Okay. So here alpha 2 is 90 degrees, right here. Alpha 2 is 90 degrees, right? Okay. So this angle is 45, right? L. Okay. So alpha 1 is correct. Okay. So alpha 2 is 90 here. Alpha 2 is okay. So alpha 2 is 90 degrees and alpha 1 is 135 degrees, right? Okay. Okay. So that means cos 90 will go to what? Will go to 0. right? So this is equal to what? This is equal to mu I by what? Mu I by 4 pi L, 4 pi L. Here minus is present, here minus 1 by root 2, so minus of minus will become plus. So you are going to get 1 by root 2, 1 by root 2 AZ cap. Okay, 1 by root 2 minus AZ cap here, minus AZ cap. So this is B4. Okay. Okay. Yeah. So now is it correct, Parasmoon? Right? Thank you, Parasmoon, for correcting this. Okay. Now everything fine now? So B4 and B3 and B2, right? Okay. So due to 1 and 5 it will be 0, right? Okay. So now write the total B field here. Now write the total B field. Now write the total B field here. So total B field, B total is equal to what? So this is I am writing this as B1 total here, B1 total. Okay. So this is at point P1, at point P1. So B1 total is equal to what? Is equal to B1 bar plus B2 bar plus what? Plus B3 bar plus B4 bar plus what? Plus B5 bar. So this B5 0 and B1 is also 0. Okay. So write down all the other expressions here. So what we got? So B2 is equal to what? Mu I by 4 pi L into 1 by root 2. Mu I by 4 pi L. Mu I by 4 pi L into 1 by root 2. It is pointing in which direction? It is pointing in negative Z direction, right? Okay. Plus B3, plus B3. Okay. So plus B3 mu I by 2 root 2 pi L, mu I by 2 root 2 pi L, and it is also pointing in negative Z direction. Next, B2, B3, B4. So B4 is mu I by 4 pi L into what? Into 1 by root 2 minus AZ cap. Okay. So B5 is 0, B5 is 0. Okay. Okay. Yeah. Okay. So just for practice here, we have done all these things here. We have done all these things. Okay. But if you observe here, whatever the B field that we got for second section, whatever the B field we got for second section, the same B field we got for what? We got for what? We got for fourth section, right? Okay. Okay. So this second section and fourth section, both are what? Both are similar. See here, the current here flowing in upward direction, and the B field is going to point into the board, and due to fourth section the current is flowing in downward direction. So on this side it will point out of the board, and on this side it will point into the board. So that means the B field due to what? Due to this second section and fourth section is going to point what? Is going to point into the board. Okay. Since both are of what? Both are of same length and the same normal distance and same alpha 1 and alpha 2 values, and hence you are going to get what? You are going to get the same result. Understood? Okay. Okay. Yeah. Next, for this one here, for this section we have determined the B field, right? Okay. So what is the B field we got? B3. So for B3, alpha 2 and alpha 1 values are different. Alpha 2 and alpha 1 values, what we got here? 45 degrees and 135 degrees, right? Okay. 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 Yeah. So this is the final result we got. So take whatever that is common, you can take here. So all are pointing in negative Z direction. That means they are going to get added up. They are going to get added up. Okay. So just consider B1 total magnitude. So just add all these things here because all are pointing in the same direction. So what you can take common here? You can take mu I by mu I by okay, so mu I by pi L you can take common, right? So mu I by pi L you can take common. So then what is left out here? What is left out here? 1 by root 2 plus what? Plus 1 by mu I by pi L na 1 by 4 root 2, and here 1 by 2 root 2, and here 1 by 4 root 2. Okay, so do this one here, do this simplification. Mu I by pi L into what? 1 by 4 root 2 plus 1 by 4 root 2, that is 2 by 4 root 2 plus what? Plus 1 by 2 root 2. So here 2 1s and here 2 2s. Okay, so here you are getting 1 by 2 root 2 plus 1 by 2 root 2. So this implies mu I by pi L, mu I by pi L into 1 by 2 root 2 plus 1 by 2 root 2 is 2 into 1 by 2 root 2. Yes or no? Okay. Okay, so here 2 2 will get cancelled. So finally we got B1 total here. B1 total is equal to what? Is equal to mu I by what? Mu I by root 2 pi L, root 2 pi L. Okay, so just I have seen this problem just before starting the session here. Okay, so that's why I have not practiced anything. So that's why I am asking, whether the mathematical calculations are correct or wrong, right? Okay, I have not checked this one here, I have not checked this one previously, so that's why I am asking. Okay, so let me know if I do any mathematical mistakes, mathematical calculation mistakes. If I do, then please let me know. So is this one correct here? B1, this is at point P1, this is at point P1. This is at point P1, right? Is this clear? Tell me here. Is this clear? Nero Lakshmi, good evening, good evening. Parasmun, Rahul Thakur, tell me here. Is this clear? So do each and everything along with me here, so that we can check if any calculation mistakes or anything happens, we can check that. Okay, is this clear? Yes, okay. Okay, so that means you have determined the B field, See, it is just appearing to be lengthier, but it is going to be, it is very simple problem, because we know how to determine the B field due to a current carrying wire of finite length. Yes or no? You know how to determine the B field due to this one, and how to determine the B field due to this one, and we know how to determine the B field due to this one. Understood? Just you have to identify the normal distance and alpha 1 and alpha 2. That's it. Okay. Okay. So if you do practice here, if you practice, then it is going to be very simple, right? Okay. Next, here what they are saying here is the same segment here, the same segment of wire is bent into what? Is bent into a semicircular shape as shown in figure. B field measured at point P2 is B2 when the current is again I. If the total length of the wire is same in each case, that means whatever the total length we are considering here also must be what? Here also it must be same length. So whatever the total length that is present, whatever the total length of wire here, okay, so the same length of wire is present here also. Understood? Now in this case here, what is the B field here? What is the B field you are going to get? You can write directly here. What is the B field at point P2 due to this semicircular wire? Tell me. See, I can divide this into 3 sections. This is 1, and this is 2, and this is what? This is 3. Right? Okay. Okay. So now, so consider this figure. right? So for this figure here, this is section 1, this is section 3, and this is section 2. So due to section 1, the B field at point P2 is 0, and due to section 3 also at point P2 the B field is 0. And what is the B field at point P2 due to this semicircular loop here? What is the B field? We already know here what is a B field. Okay, so here I am representing here B2 total here. B2 total is equal to what? Is equal to, so B2 total is only due to what? Is only due to second section. Due to first section and third section it will be equal to 0, and hence the total B field will be only due to the second section, that is due to this semicircular loop. Okay, so what is the B field at point P2 you are going to get? So that is nothing but what? Mu into what? Mu into I by what? Mu into I by 4 into radius of this semicircle, that is 4 into R. 4 into R. Understood? And what is the direction of B field? The direction of B field will be into the board. Into the board. So that means it is in negative Z direction. So that means what is the magnitude of B field here? What is the magnitude of B field? Total B field at point P2. At point P2, what you are going to get is nothing but what? Mu I by 4R. Mu I by 4R. Okay, so let us consider this equation as 2. This equation as 2. Right? Okay, so what is the B field at point P1 we got? What is the B field at point P1 we got? That is nothing but this expression. Yes or no? Okay, so this is equation. Okay, so this is equation 1. This is equation 1. So what they are asking here? They are asking the ratio of what? B1 total to what? B1 total to B2 total. Okay, so that means they are asking. So they are asking B1 by B2 here. So that means they are asking B1 total by what? By B2 total. B2 total. Okay, so what you are going to get? Tell me what you are going to get. So that is equal to mu I by root 2 pi L divided by what? Divided by what is B2 total? What we got? Mu I by what? Mu I by 4R. Mu I by 4R. Okay, so this is the ratio we got. Now here mu I and here mu I will get cancelled, right? Okay, so here we are going to get here 4R divided by what? Divided by root 2 pi L. 4R divided by root 2 pi L. Now tell me, what is the value of R here? What is the value of capital R? Can you tell me what is the value of capital R? What is the value of capital R? Tell me. Rahul Thakur, Parasmoon. What is the value of capital R? See, they have said, they have given one clue here. What is the clue they have given? What is the clue they have given? The length of what? The length of the total length of the wire here, and the total length of the wire. The total length of the wire in figure 1 and the total length of the wire in figure 2. Both are what? Both are same. Both are same. Yes or no? Now if you observe here, this first section length is L, and here this first section length is also L. Understood? And here this section length is L, and here this section length is also L. Understood? Next, here this length is L, and this length is 2L, and this length is what? Again L. So L plus 2L plus L, that is how much here? 4L. Understood? So from here this is L, 2L, and this is also L. So total is 4L, and here L, and here L. So total 6L here. So the total length of this wire is how much here? The total length of this wire we are getting as what? We are getting as 6L. 6L. Understood? Now here in this wire also the total length must be what? Total length must be equal to 6L. So in that this length is L, and this length is what? L. So L plus L will be what? 2L, and hence this perimeter of the semicircle must be what? Must be equal to 4L. Yes or no? Because the length of this wire and the length of this wire must be same. Here we are getting 6L, that means this total length must also be 6L. So the first section is having the length L, and the third section is having the length L, that means 2L, and remaining 4L must be what? Must be the length of what? Must be the length of this second section. Understood? Okay, so that means from here From here, what we can say here? What we can say? So the length or the perimeter of this semicircle must be equal to what? Must be equal to 4L. Must be equal to 4L. Now we know the formula for the perimeter of the semicircle. If it is total circle, then it must be 2 pi r. Yes or no? It is semicircle. That means the perimeter is pi r. Pi r. Okay. So here pi r. So this is the perimeter of the semicircle. This must be equal to what? This must be equal to 4L. This must be equal to 4L. Okay. So therefore, from here we will get r is equal to what? R is equal to 4L by what? 4L by pi. We are going to get r is equal to, capital R is equal to 4L by pi. Okay. Okay. So now see here. Okay. R equal to 4L by pi. So just substitute here. Just substitute that. Okay. So here in this expression, so 4 into r is equal to what? R is equal to 4L by pi. R equal to 4L by pi. Okay. So here you are having root 2 pi, here L. Okay. So do the cancellation here. Here L cancels, here L cancel, right? Okay. Okay. So here we are having a 16 by root 2 pi square. 16 by root 2 pi square. So that is I can write 8 root 2, right? 8 root 2 by pi square. 8 root 2 by pi square, right? Okay. That's it now. Okay. So what is the answer here? 8 root 2 by pi square. So 1.414, okay, 1.14 into 1.414, okay, 1.4 into 8. 8 4s are 32, 8 1s are 8, 3, 11, okay, 112, that is 11.2. So you will get approximately you will get 11.2 divided by what? Divided by pi square. So approximately you can take pi square as 10 here. So that means you will get the answer 1.12 or 1.13, 1.14 like that, right? Okay. Okay. So pi square 11.2 by pi square. Okay. So you will get approximately here. You will get approximately you will get 1.12, or it may be in the range, from 1.12 to 1.19 or something. Okay, it may be in this range here, 1.12 to 1.19 it may be, right? 1.14. Okay, fine. Okay, if you substitute, it depends upon root 2 value. If you substitute 1.414 and here if you substitute exact value of pi square, so then you are going to get the exact answer. Okay, so Rahul Thakur, you have done the calculation, right? Okay, so you are getting 1.14. Okay, fine here. So therefore this ratio you will get as 1.12 or 1.13 or 1.14 or 1.15. So all are correct only here. So just we have done, I have written some approximate value here, that's it. Okay. 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 So just practice this problem again here. So practice this problem again once the class is completed. So practice this problem again so that you will get familiar how to determine this alpha 1, alpha 2 and normal distance and all these things, and how to apply these formulas to these problems. Okay, so that you will get by practice here. Okay, so just practice again this problem. So after completion of class, what you will do here is you just close all your notebooks and try to solve this problem here. Try to solve this problem on your own. Understood? Okay, so do it regularly here. On every day you have to follow the same thing. Okay, once the class is completed, take some rest for half an hour or 1 hour. So later, whenever you feel comfortable, so at that time just revise each and everything without looking into the book here. Okay, Okay, so if you try to solve on your own, then it is going to be crystal clear here. It is going to be crystal clear. Okay, so if you are getting, while solving like that, if you solve on your own, you may get some doubts here. So if you are getting any doubts, immediately in the next class itself, you can ask me. Understood? Okay. Okay, so don't hesitate to ask any doubts. So, right. Okay, so I hope this problem is crystal clear. Right? Okay. Okay. So is everything crystal clear here? Tell me, Rahul Thakur, Paras Moon. Tell me here, is everything clear? Right? If you are having any doubts, let me know here. Is it clear? Rahul Thakur, Paras Moon. Tell me. Is everything clear? Yes? Okay. Okay, yaar. So, okay then, I'm going to wind up the session with this, right? Okay. So, tomorrow exactly at 4 p.m. Tomorrow also exactly at 4 p.m. we are going to start the session, right? Okay. Okay, yeah. So if I find any further some interesting problems based on Biot and Sever's law, I will we will discuss those problems. So or else we can start what? We can start Ampere's law. Okay, so if I find any problems, I will discuss those problems tomorrow, right? Okay, so after completion of those problems here, tomorrow, if possible, we will start what? We will start Ampere's law. Right? Okay. 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 So with this, I am winding up the session. We will meet exactly at 4 p.m. tomorrow. Okay. So until then, take care. Bye bye.